This is section 1.7a, transformations of functions. First, let's talk about vertical shifts. And this has to do with what we saw in the last lesson when we were talking about parent functions and their children, or the functions that come from them. And so here we have the parent function indicated in gray. And you can see it's a parabola f of x equals x squared, indicated with this gray curve. And the child function is indicated in black, and that is x squared plus 2. And this first screen is just to show how vertical shifts work. Vertical shifts are simple. You just add if you want to go up, and you subtract if you want to go down. All right, so this is a shift of 2 units upward because we simply added 2 to the function, x squared plus 2, and therefore we're adding 2 to all the different y values for the parent, and that's why we have a curve that is shifted 2 units upward. Horizontal shifts look like this. With horizontal shifts, the constant goes inside the x, or it goes with the x. And so, the difference is with vertical shifts, it's outside of the function. And with horizontal shifts, it's inside the function. Now, the reason horizontal shifts are a little bit tricky, and you might remember this a little bit from chapter 3, but it's okay if you don't. The reason horizontal shifts are a little bit tricky is just that a shift to the right is negative, whereas a shift to the left is positive. And that's kind of contrary to what we might guess, but it's just something you have to keep in mind. Now, you can prove that to yourself simply by testing values. Okay, so let's say that right here, where I'm circling now, I have the point 2, 0. Okay, I have the point 2, 0. Well, my x-coordinate here is 2. And 2 minus 2 is 0. 0 squared is 0, and that's why I end up with this y-coordinate of 0. Okay, so it checks out. It's something you can verify just by plugging in numbers. But remember that right shifts are negative, left shifts are positive. So this is how to keep it all together. And you don't have to write down every word on this chart, but it's good at least to write down the numbered portions. Okay, write down the numbered portions. And, I'm referring to, of course, just these here. Those would be key. And make sure that you have it written down somewhere, because you're going to need to keep it straight, and you're going to need to refer to it perhaps in the beginning until you get used to it, and then it'll be second nature for you. So a vertical shift of c units upward is h of x. H of x simply that indicates the child function, so to speak. F of x is the parent. So you add a constant to the parent in order to get a vertical shift upward. You subtract a constant from the parent in order to get a vertical shift downward. You subtract a constant within the parent function in order to get a shift of c units to the right, and you add a constant within the function in order to get a shift of c units to the left. Okay, so make sure you write down this chart here. Now let's talk about reflections. A reflection in the x-axis happens when we take a negative of the whole parent function. All right, so if my parent here indicated in gray is f of x equals x squared, and if I take a negative of the whole thing, that would be negative x squared, and I end up with the child function h of x, which is just like the parent, except it's been reflected in the x-axis. Think of the x-axis as acting like a mirror here, and the child is a reflection of the parent in that mirror. So that's how a reflection in the x-axis works. You just take a negative of the whole function. Now, reflection in the y-axis is a little different. Okay, here I have my parent indicated in a gray curve, and that parent is root x. The child function here is root negative x, And so we have a reflection in the y-axis where the y-axis is acting like a mirror, and the child function is a mirror image of the parent function using that y-axis as a mirror. So that's how a reflection in the y-axis works, is you take a negative of the innermost x. Okay, reflections in the x-axis is taking a negative of the whole function, but reflection in the y-axis is taking a negative of the innermost x, okay, within the function. So in general, reflections in the coordinate axes. Reflections in the coordinate axes of the graph of y equals f of x are represented as follows. And so you definitely want to, write down these two parts here, because you need to keep straight that a reflection in the x-axis is a negative of the whole thing, whereas a reflection in the y-axis is just f of negative x, where you replace each x with negative x. All right, let's look at some examples. The first example, for the parent function f of x equals x squared, perform the following operation algebraically and graphically. Shift 2 units down, then reflect in the x-axis. All right, so I'm going to walk you through the first one, and then you'll do the remaining examples on your own. So what does it mean, perform the following operation algebraically and graphically? Well, first let's do it algebraically and then graphically. And the best thing to keep in mind for these kinds of problems is just do it one step at a time. Okay, so right now let's go through the algebraic part. Shift 2 units down, what does that look like? That would just be x squared minus 2. Okay, I've got my parent, x squared, and I'm only looking at the shift of 2 units down for now. I'm not worrying about anything else. Let's just do one step at a time. Shift 2 units down, and that would just be x squared minus 2. Vertical shift of 2 units down. Okay, now, next step. It says then reflect in the x-axis. So the next step is I take that x squared minus 2, and I do an x-axis reflection on it, and that would be taking a negative of the whole thing, negative quantity x squared minus 2, and that simplifies to 2 minus x squared. Right? So 2 minus x squared is the child function, which is equivalent to the parent x squared being shifted 2 units down, then reflected in the x-axis. Now moving on to the graphical part, you just graph, and notice how this graph is exactly what the problem describes. It's a shift of 2 units down, then a reflection in the x-axis. All right, now let's look at this, because sometimes students get confused about it. Now, this apparently is a shift up. And so the question is, well, why does it say shift down? Because you have to backtrack. When you start with that parent function, you just have an upward-facing parabola. And of course, it's a very rough sketch, but your upward-facing parabola is something like that. That would be your parent function. Well, if I shift that first, well, the shifted one is going to be down here. The shifted one is going to be down here. I'm doing the shift first, and then I reflect it. Okay, so that shift down of 2, once I reflect it, is going to look like a shift up of 2. Okay, that's just because the x-axis is acting like a mirror. Okay, so if the x-axis is acting like a mirror, then what is down here is going to become up. Okay, so that's something to keep in mind with vertical shifts and reflections. Order does matter. A shift of 2 units down and then a reflection in the x-axis would be equivalent to a reflection in the x-axis and then a shift of 2 units up. All right, so order matters. Just do it in the order in which things are given. To illustrate that, let's look at the next example. For the parent function f of x equals x squared, perform the following operation algebraically and graphically. Reflect an x-axis, then shift 2 units up. All right, we're going to prove to ourselves how this is equivalent to what we did on the last screen. You should do this on your own. First, do it algebraically, just as we did in the last screen. Take it one step at a time, and then do your graph. So pause the video, do that on your own, and then resume when you have your answers. Okay, so doing things one step at a time, as usual. It says reflect in the x-axis first, so I'm going to do that first. That's why I just have negative of x squared. Then I have a shift of 2 units up, so it's negative x squared plus 2. And negative x squared plus 2, of course, is equivalent to 2 minus x squared, and I can see that that's what I ended up with on the last screen. It's just that it was described in a different way. And so, of course, the graph will look exactly the same. Reflect in the x-axis, then shift 2 units up. Okay, so you know, if I think about it in the way that it's described, you know, my parent would be here. Then I reflect it. Reflecting it gets me down here. And then, of course, after I reflect it, then I shift, and I end up with the same graph. Okay, so this is just to emphasize that the order in which transformations are described does matter. Next example. For the parent function f of x equals x squared, perform the following operation algebraically and graphically. Shift 1 unit left, 2 units up, then reflect in the y-axis. Okay, so pause the video, do it step by step, and then resume when you have an answer. All right, step by step. It says shift 1 unit left, so we're going to take care of that first. We have plus 1 within parentheses, because remember that left is plus and right is minus. So we have plus 1 in the parentheses. Next thing that happens in the transformations is 2 units up. So that would be x plus 1 squared plus 2. Notice how we're building this little by little. Then reflect in the y-axis. Reflection in the y-axis is where you just do the negative x, the innermost x. So we have negative x plus 1 squared plus 2. And rewriting that is simply 1 minus x squared plus 2. So looking at the graph, this is our graph. And we can see that it follows the description perfectly. Okay, let's say that I just start with my parent. Again, these are just rough sketches, right? But you get the idea. If I start with my parent, the parent would be somewhere down here, just right at the origin. Okay, then I shift 1 unit left. Well, that's going to get me over here, shifting 1 unit left. Then I'm shifting 2 units up. That's going to get me over here, shifting 2 units up. And then here's the key step. Reflect in the y-axis. Now notice, this is 1 left here, but then that 1 left is going to become 1 right because I'm reflecting in the y-axis. I'm using the y-axis as a mirror. And then, of course, I'm going to end up with my final answer, my final curve, indicated in black here, this parabola. Another example, for the parent function f of x equals x squared, perform the following operation algebraically and graphically. Reflect in the y-axis, then shift 1 unit right and 2 units up. Okay, so pause the video, do it on your own step by step, and then resume when you're done. Okay, step by step, reflect in the y-axis, that's the first thing. And so I put a negative in the innermost x. Negative x within the parentheses. All right, that would give me a reflection in the y-axis. Then a shift of 1 unit right. Okay, now here, this is important. The temptation could be just to put minus 1 right next to the x, because, you know, the minus 1 would be a shift of 1 unit right. But here's the thing. Remember that you have to go to the innermost x. And since you are doing, you're doing the shift to the x, you need to put that minus 1 right by the x. Okay, and then that negative sign here, that's going to get distributed. Okay, so that's That's something important to remember. Keep that in mind in cases where you're doing the shift after the reflection. Okay, so that takes into account the shift of 1 unit right. And then finally, 2 units up is going to be that simplified 1 minus x squared plus 2. Notice that from here to here, okay, from the second to the third step, all I did was rewrite. I really didn't do anything but rewrite. Okay, so don't be confused by that. And then finally, from the third to the fourth step, of course, that's where I took into account the shift of 2 units up. And so this is what I end up with. I end up with 1 minus x squared plus 2. And this is what the graph looks like. And you'll notice it's exactly the same graph. But see, the transformations were described in a different order. We end up with the same graph, but the order in which you describe transformations does make a difference. Okay, now let's go through this, the graphic sketch again. If I start with my parent is just here at the origin. Again, these are terrible parabolas, but it's just to give you an idea. So we got your parent, and then following along with the words of the problem, it says reflect on the y-axis. Well, notice how this is symmetric about the y-axis. So a reflection in the y-axis is going to make it look exactly the same. So I don't even need to rewrite this, to resketch this parabola, because reflecting it in the y-axis, or rotating it if you like, 180 degrees about the y-axis, will give you the same exact shape. Okay, then I'm going to shift 1 unit right. That would bring me over here, shifting 1 unit right. And then finally, 2 units up, and that would bring me right here, which is where my final answer is. Okay, so this is just to introduce you to shifts and reflections, which are collectively called transformations. We're going to learn some more transformations in the next section, but for today, you're just responsible for shifts and reflections. And just tying it into the last lesson one more time, notice how a transformed function is really just a child function. Okay, you always start with a parent, and then from the parent function you do different transformations to get the child function. Classwork, page 80, please write down these numbers, and we'll work on those in class.